Well, I think the post-it note explains it all. Retro PC Durham, Chris here with another vid. This power supply, as you can see by the letters written here, suffers from a common electronic condition known as coil whine. And coil whine is caused, it's a perfectly natural phenomenon. I don't know if that's the correct word. It's a perfectly natural thing that's caused in electronics sometimes whenever you have copper coils, or sometimes it doesn't necessarily have to be copper coils, but when you have coils that are generally put inside of electronics to help to regulate the flow, the current of electricity passing through the device, in this case a power supply, sometimes what will happen when that current is traveling is it will cause those coils to vibrate, right? The movement of electricity through it will cause it to give off some energy, in the case of kinetic energy, to cause it to vibrate. And that vibration is like hypersonic, might be the word, correct word, and it causes it to create an audio disturbance, in this case a whining noise. So I'm going to flip this on and we'll listen to what it sounds like. I've got this plugged into actually will probably be the system board that if I get this fixed, it'll be used with. But you'll be able to hear that changing pitch a little bit. So that sound is actually one of the copper coils in this power supply doing that vibrating. Now, I've already tried to do a little bit of work to fix this, and obviously it hasn't been resolved yet, but what we're going to do is actually take a glue gun and use this hot glue, which is non-conductive, and put it all over, just goo it all over the coil that's causing the problem. And what that will do, right, is fill in the gaps and stop the coil from being able to vibrate, which hopefully will eliminate the coil whine. So I thought I would record my attempt here for posterity and see if it actually works, something you might want to try on your own. And if I fail, then you can witness me sucking at this. So what we're going to do now is we'll power this off. Something that you want to be aware of whenever you're using any kind of high voltage is something like this is going to carry some residual current inside of it. So what happens is you've got capacitors, and capacitors obviously are designed to also, take electricity in and help to move it around or keep it, change its level or something. They have different purposes, obviously, but they're all generally the same thing. It's to make sure that electricity is going to the right place at the right size at the right time. Capacitors hold a certain charge. It takes some time for them to dissipate. And in the case of something like a power supply, you will often have capacitors that are rather large. And we'll take this off and I'll show you here what we're talking about. So on this particular PSU, we've got two fans in here, and they're wired in, and there's glue that's actually on them here. And I don't want to try and take that off because I'll probably end up breaking the plastic housing on this older power supply doing so. So we're just gonna kind of finagle this around and sit it upside down so I can show you what's going on here. So what I tried to do, because I couldn't quite figure out which one of these coils at first was causing the problem. So I just tried gluing manically. So I put a bunch of glue down on this coil. I also put a bunch of glue down on this coil here. And then this one in the back corner, I'm going to try to make sure I don't touch an electrode. This one down in this corner here is the one that actually, I noticed some of the winding getting a little more fluctuated once I got some glue on it. But it's the hardest to reach, of course. So what we'll need to do is take these cables and move them out of the way. so that we can get down to it, and then we'll be able to fire some glue down into that. Now, so what I wanted to note here is you've got, you know, regular size capacitors down here, and then you've got these big boys up here, right? You do not want to touch these capacitors by accident at all or anything else on this board until it's had a chance to dissipate. And that means, you know, let them drain. So there's a couple ways you can try to do that. If it's plugged into the board, I left it plugged in, held you hold the screwdriver to the start button and tap it a couple times, or you know, you switch the CMOS thing, or you hold the screwdriver against the connectors for the CMOS battery. You know, there's a number of different ways you can try to kind of make like a connection current so it can kind of drain what's left. But for the most part, the best thing to do is just wait a little while, right? Don't be in a huge urgent rush to get this thing opened up and start touching things and moving things around, because it's better to spend a little bit of extra time and be safe than it is to blow yourself up or very seriously hurt yourself with one of these. If it's still holding, even a bit of a charge is enough to cause you some serious physical harm. And, you know, take it from me, someone who, while not from a capacitor, has electrocuted himself no less than 2 times by being an idiot. It is not an enjoyable feeling having the adrenaline rush that your body goes through when it realized that you almost killed yourself. And it's certainly not anything that I want to purposely experience or take the chance to experience again after learning those lessons the hard way. So what we do is just wait for that to cool off. In the meantime, we'll take a look and see what we're going to use here. This is just a simple glue gun. You don't need something extra special. It would be nice to have something that had a little bit of a longer neck without the built-in standees to be able to kind of get in there and drop the glue in. But it is what it is. We're going to use what we've got here. As you can see, that the stick of glue that I had here was mostly used up getting these other pieces in here, but we're going to put this guy in here and keep it going until we smother this piece completely. I don't want to necessarily take this whole thing apart to get down to every little last nook and cranny. I could, though, maybe once this has had a chance to go down a little bit farther, maybe we take these 4 screws, I believe, are the only ones securing the circuit board down. Maybe we could do that, and we can take this out of the case, and that will actually give us some better access to the board here. So that's what we're probably going to do to get this going. We'll carefully unscrew these guys. I'm going to move the glue gun out of the way here, actually, so we're not too crazy here. All right, let me okay. Hopefully taking this out won't be too, where did I put the other screw there? Hopefully taking this out won't be too wonky. Again, with certain components not being removed and that type of stuff. I'm not going to remove the second fan. Well, hopefully if I don't have to remove the second fan, but even then, all the connections to the power supply input and the switch, I don't really want to have to unscrew all that stuff and remove it as well to get access to this. All right, let's make sure we don't blow yourself up, Chris. These generally don't take all that long to drain, but again, it's always something that I'm very wary of, not wanting to do to myself. Okay, so we should be okay now to, jeez Louise. Doesn't help also being kind of klutzy at the same time. All right, so we've got this baby up and running now. So again, you know, be very careful when you're doing something like this as well. The fact that when you take this out of the power supply, put down the screwdriver that can create a current contact. You're going to be exposing the bottom of the circuit board here as well, which means, you know, you don't want to accidentally touch the solder points on these ones by accident and mess yourself up as well at the same time. So it looks like, you know, this is pretty solid in here. I don't know if I'm going to be able to make it down the way that this is bent and get any glue around the back of this, but I definitely have a better way to get, you know, I could definitely get better access into here to gunk some glue into this spot. So that should be pretty good now, as goofy as this all looks. What a mess. Okay, so let's plug in our glue gun now, and we will give that a moment or two to warm up. All right, we should be, well, we are warmed up and we should be free of any remaining current. So we're just going to start getting into this and trying to goop as much of this stuff as we can across and into the power supply, or the power supply. Yeah, the power supply inside this part here. Now, what am I getting on here? This is, oh geez, you look out, oh geez. All right, let's just keep gunking this stuff in. I am by nature not a very crafty person, so like doing stuff like using a glue gun, I'm already bad at. So on top of that, trying to make this work without making a huge mess feels like it's something that's, you know, almost completely out of my scope of ability. And the worst part is it's really not something that should be difficult to do, right? I mean, we're talking about a glue gun. We're not talking about something incredibly complicated. Okay, I have crammed a very large amount of glue in and around this now. It is quite disgusting and obnoxious and looks horrible and messy. And that's perfect. That's exactly what I wanted to achieve. No one's ever going to see this, except the fact that I'm making a video of it and putting it on YouTube for everyone to see. But let's not get caught up in the details here. So hopefully this is going to be enough. I don't foresee how I could possibly cram any more glue onto this without completely disassembling and actually removing components from the power supply assembly to make this work. So we're gonna hope for the best that this is gonna be enough, and reassemble now to test everything out. I'm just gonna move the couple extra glue gun sticks in the bag here. I'm gonna move those out of the way, and we're gonna screw this back together. Am I using the right? Make sure I use the right screws here, because everything got knocked over while I was moving the power supply around. Okay, I've got 4 screws to hold down the circuit board. And that's number 1. Put number 2 over here. I won't tighten these just yet. We want to make sure that we got everything lined up the way it should be lined up. No, it's not the best angle to see what I'm doing here as I move this around. I'm just trying to shift it back and forth for the standoffs where the metal has been bent in the power supply enclosure here, and get everything in and started, and then we'll tighten them up afterwards. Uh-oh, that missed. There's a blue wire that's kind of standing off from the rest of these, and it's like right over top of where this screw hole is. This guy here. So it's possibly too the angle that I'm coming in at is not the best. So let me just move that out of the way temporarily. Okay, now we got it. Okay. So we will now tighten this up. We'll tighten this up. Tighten this one up. And we'll tighten that one up. And then this guy here has to get wrapped around the cables, and we slide him into place and twist him, and that gives us that part secure. And then lastly, we bring this over top, and we'll keep hitting this stand here I have for my phone. I don't have like a proper tripod, so it's one of these like selfie camera with a built-in LED light things. It's not the ideal piece of hardware for what I want to achieve. I mean, it's nice that it's got the light integrated that I can move around to be able to, you know, cast disgusting shadows over everything I'm doing. All right, so we're all screwed up, and oh, what's this over here? That's just, oh, that's a little label here. It's showing this PR brand 550 watt switching power supply. Oh, do not remove this cover under any circumstances. Trained service people only. No serviceably components inside. I didn't read this before I opened the cover and serviced components inside. Oh, well, the warranty is void if removed. Wow. Too late for that. Okay, let's try this out now and see how things go. So we're gonna make sure we're off there. We're gonna plug our power back in. We're gonna plug our cables in over here, and then we're gonna jump start this, and let's pray. I don't know, just wish it goodness. That doesn't sound any better. In fact, it may sound actually worse than it did before. It's possible that I completely failed at doing this, which is kind of disappointing. I'm sad now. Okay. Screw it. We're gonna we've taken her back apart, and we're actually gonna try and cram more glue down on this one. Something I did notice is this the glue that we bought for this glue gun. I guess it's not the original glue that it would have come with, and it's not the Mastercraft glue that's probably recommended to be used with it, and it doesn't fit. This glue doesn't fit very well. So I end up, the trigger piece on the back of the glue gun, which is supposed to, push the glue through, isn't catching the stick. Like the stick's just a little bit too thin for it, and it ends up not traveling through very well. So I end up having to like push it with my hand. Anyways, I'm just trying to like get this other coil, which I really hadn't glued all that well the first time when I had this open. I just assumed, because I couldn't really hear which one of these coils the whine was actually coming from. There's a trick you can do. Where you take like you take a piece of paper and you make it into a cone, and you try to like hold it up to the coils and listen to it and see which coil is the one making the noise. Yeah, that didn't work. I think it's just the coil is just the noise is just so loud that it was like impossible to distinguish which one it was that was making the noise. Anyways, this is a mess. This is an absolute disaster, unmitigated disaster, and hopefully it's going to work now. Now that we've overglued not one, my friend. In fact, two. Two of these coils now have been overglued, and we're going to see if we can make this work now as a result of making these changes. Okay, so let's put this back. The way we found it now, and hope that it works. And then if it does work, great. If it doesn't work, then I need to decide if I'm still going to use it in a build. So when it comes to coil whine, it doesn't actually have any negative effect on the operation of whatever the electronic component is. As I mentioned earlier, it's a perfectly natural phenomenon caused by the current traveling through that coil. As it's regulating the current, it can give off some loss, right? As energy travels, it might come off as heat, it might come off as light. In this case, it's coming off as the kinetic energy, right, causing the coils to vibrate, and that creates that harmonic disturbance that doesn't sound harmonious. It sounds quite irritating, actually. All right, so the only other possibility is if these sounds actually coming from the transformer, or one of these smaller transformers, which do have copper coils in them as well. If those are what's causing it, pouring hot glue on it isn't going to resolve it. They're already coiled up and wrapped up. You're not going to be able to resolve that problem. It's usually just having to end up replacing them. So hopefully, that's not the issue, and I've actually somehow solved it by buttering up the second one of these. But that being said, if it turns out that I don't resolve this, the decision has got to be: do I still end up even using this power supply in a build, or do I set it aside and not use it? I can keep it around to use it for testing purposes, because it still works. It still works perfectly, but it's annoying, and it's not like if you get coil whine in something like your GPU, your graphics card, may not be as big a deal. If it's inside of a case, you might not hear the coil whine at all. But in the case of a power supply, you're going to hear that all the time because it's got external access to the system, right? It's got that fan sitting out the back end of the case, and it's always going to be something that's going to be noticeable. So we'll just, we'll try it out and get this, finish getting this screwed together, and then we'll plug it in and we will listen to the sound of either coil whine or no coil whine. Hopefully it'll be the no. Hopefully it'll be the no. All right, plugged in, power on, jumper. And yep, it's still there. It is definitely still there. So an unsuccessful try on this project to get this thing to go. The post-it note doesn't get removed, unfortunately, and then we got to decide whether or not we're going to use this in a system or not. Maybe what I will do is, if I'm going to build, as I build out the systems, I'll try out this in a couple of different cases that I have sitting here, and if one of them happens to dampen the noise of it at all, we'll be able to use it. Otherwise, it's going to have to go sit aside and probably not go into a system. So I'm going to make an assumption that it is one of those transformers. I believe those are called transformers. That's ending up causing those trouble, and you know, you can't really solve that by pouring hot glue on it, as far as I know. So hey, if you have an idea on what I could do to make this work, if there is another fix that I'm not aware of, please let me know in the comments, and I'll give it a try and do a follow-up video and give you all of the accolades for having the bright idea. But until then, this thing's gonna we'll have to decide what I'm gonna end up doing with it. Thanks for watching, and have yourself a great day.